Hello everybody, today we are working on some more on functions and their graphs for pre-calculus. The first thing, let's talk about, I have this graph on the screen, and we are looking for on which intervals the graph or the function is increasing, decreasing. So we are looking for intervals. You know, intervals are x values only. Intervals, on which intervals the function increases or decreases. Okay, so we are looking for this. Now, how do you figure it out, increase, decrease on this? There is an easy way to do this. Like I have this graph, and you know, when there is no point up there or something, so it's just, I think it's just stopped. It's not continuously going. But let's figure it out. That's besides the point. Function increase, decrease. Now, look it up here. I know increase goes something like this. When I draw a tangent line here, like for example up here, I pick any point, okay? Any points up there, up here, and I'm gonna pick all these points, and I'm gonna draw a tangent line. When I draw a tangent line, like a small line right there, this tangent line means when the line touches the graph once. That's a tangent line. So I'm in my tangent line, that one was bad. Let's go back. So I draw a tangent line up here. You know that tangent line is positive, and the slope is positive, like it looks positive. You know the line goes like this, that's a positive slope. And if the line goes like this, that's a negative slope. And I have a really good cartoon face for that you guys can remember. Like this, like that, that's positive, that's negative. The nose stays undefined, and the horizontal goes like undefined, something like this. Okay, that was bad. Let me try again. I'm forgetting it. It was been a long time ago. Positive, negative, undefined because it's a U, and then undefined, and then we have this 0. So positive slope, negative slope, undefined, and 0. Okay, so these are all positive slopes. Like, do you see positive slopes? So positive slope means it's increasing. So I started with 1 right there. This is 1. So from 1 to infinity, the graph is increasing. So I'm gonna say increasing on parentheses 1 to positive infinity. And it's also increasing here. When I draw tangent lines, you see that up here? It's also increasing. So I'm also increasing. I can put U means union, like together. I do negative infinity, and the smallest number goes first. So negative infinity to negative 1. So the graph is increasing on all of those. Now, what about this? Do you see this? The slope is kind of 0, like a horizontal, like a 0, like that one. About it's 0. So, but I know this is negative. Like from negative 1 to positive 1, it's decreasing. So decreasing, the graph is decreasing on negative 1 to 1. So that's decreasing and that's increasing. And this is exactly the way we teach in AP calculus, increase, decrease. Okay, what else we need? We need a relative maximum or minimum. So I can also figure it out, a maximum and minimum from the graph. You know, the maximum means this is maximum, this is the maximum portion of the graph, and this is the minimum portion of the graph. So you can say relative maximum, relative, okay, not, there is another max and min too, but we're talking about right now relative max. Relative max is at x equal -1, and relative minimum at x equal +1. Okay, so these are relatives, relative max and relative min. Okay, let's try some more things about even and odd. And we figured out all these things from the graph. Maybe further when we go into pre-calculus more videos, we're gonna find out all of this stuff using algebraic function, like algebraically we will figure it out. Okay, what is even and odd functions? Even and odd functions. Okay, the thing is, the function is even, the function is going to be even if when I plug in -x in the function, I'm supposed to get positive function, the same function, but it's going to be positive. Then it's even. For the odd, when you plug in -x, the whole function changes to negative. So that's odd and even. Now, let's do one example for this, for odd and even. For example, I have h of x equal x to the power 5 plus 1. Now find out if this is even, odd, or neither. So I'm gonna do even first. If this is -x, so I'm gonna plug in -x in this h function. So -x to the power 5 plus 1, it will give me -x to the power 5 plus 1, and that's what I got for the function, right? So you know the function is not just like original. Original was everything positive. This is negative. So it means this is not even. This is not even, not at all. And we were looking for even right now. So this is not even because I'm not getting exactly the same original one. Let's figure it out if this is odd. So I'm going to do h of x equal x5 plus 1. And odd means I'm going to plug in that negative. So again, this is -x to the power 5 plus 1. It will give me -x5 plus 1. And you can tell this is not odd either, because odd means the whole function turned to the whole function is supposed to be negative. So the function is not odd in this case. Are we clear, guys? So the function is not odd. If it's not odd, then it means it's neither. Okay, let's go for the next one. Even function in y-axis, symmetry. Okay, the graph of even function in which f(-x) is equal f of x is symmetric with respect to the y-axis. Okay, so when we get even function, this is even because when I plugged in -x, I'm supposed to get original function as it is. So it's symmetric with respect to y-axis. Now, if we do odd functions and origin symmetry, so let's try that. If we plug in -x and we get negative f of it, like the whole function turned to negative, then it's symmetric with respect to origin. Odd is symmetric with respect to origin. So symmetric with respect to origin. Okay. Okay, let's try some examples for evaluating piecewise functions. So I have a piecewise function. The question is evaluate piecewise function. Okay, the function that I have is c of t, and I have that bracket. This is 20. The restrictions for this is if 0 less equal t less equal 60. Next, I have 20 plus 0.40 t minus 60 if t greater than 60. So that's what I got. Now, the question is asking, find C40 and C80. Now, that's a good question. Pay attention here. C40, and I have two pieces in this piecewise function, like two pieces the function CT has. So how do I figure it out? I know C40 means I have to plug in this X40 in the function. But where? Should I plug it in here, or should I mean, this one doesn't have anything, but should I plug it in here? You have to check your restrictions really, really carefully. So they said 40. Do you see this says t is greater than 40, and greater means the alligator mouth is towards t, so that's why t is greater. T greater than 60. So 40 doesn't fit in here. But this one says t less or equal 60. So we can go less than 60, or we t go greater than 0. But we have a 40, so we know it's 0 of greater than 0, but it's less than 60. So I'm going to use this 20. So I can say C40 is equal 20. Since we don't have anything, you know that there is nothing there to plug in. But I can tell if it's t less or equal 60, which means 40 fit in there, then it's 20. For 80, you know t greater than 60. So anything that greater than 60 can fit in here. So I'm going to plug in that C80 here. 20 plus 0.40, 80 minus 60. And the question is going to give me 28 when you solve. So up here, that's my 40 is 20, and this is 28. So that's my answer, and that's how you solve a piecewise function. Okay. There is another thing in pre-calculus that you guys gonna see it, and also this is in AP calculus. So this is what we have: definition of the difference quotient of a function. Okay, different quotient, difference quotient. Difference means subtraction, quotient means division. So what is that supposed to mean? You have an expression for this, and that expression is f of x plus h minus f of x over h. This is the expression which is called difference quotient. This is a difference quotient. Difference quotient is right there. Now, if you have a question, for example, evaluate difference and simplify a difference quotient. Evaluate and simplify, okay? Evaluate and simplify difference quotient. Okay, so my function there, if f of x equal negative 2x squared plus x plus 5. So find and simplify the expression. So now I'm using this expression to solve this. Okay, closely pay attention. I need this portion. I'm going to write this in, I need this portion first. How would I figure it out? You're going to go, I need this expression, that I'm going to use this formula up here. But before I plug in the formula, I need this first, and then we're going to figure it out that, and the h is going to stay as an h. X plus h means this whole thing is an x. So wherever I see x in the function, I'm going to replace it with x plus h. So let's try that first. Wherever I see x, I'm replacing with x plus h. Now let's plug in negative 2 x plus h squared plus x plus h plus 5. Now let's solve this. And you know this is squared, then there is an easy way to do this. Negative 2 is going to stay anyway. You multiply x, I mean this is a shortcut, okay? Otherwise you can do x plus h and x plus h, two of those, and you do the distributive property, which is also called a FOIL. So you can use this and figure it out. But I'm going to tell you easy way how to do this. Multiply x twice, so that's going to be x squared. Then you leave the space here, and I have plus multiply h twice, it's going to be h squared. And it's a plus sign, so plus positive times positive is positive anyway. Now, plus is going to stay here too, that one. Okay, so what do we do in the middle? 2 times this times this. 2 times x times h, so it's going to give me 2xh, and that's the easy way to do that. Plus x plus h plus 5. Okay, now let's solve this further. Distribute that negative 2, so I'm going to get negative 2x squared. I did that. Negative 2 times 2 is negative 4xh, and negative 2h squared. And I'm going to remove the parentheses so I can combine my like terms. You know, the one that is invisible one, you can distribute positive 1 times x is positive x, positive 1 times h is positive h. Okay, so this is what I got so far. Now, none of the terms are like terms, or I can cancel them out or anything, so I'm going to leave this alone. Now, in the first one, do you see? I need this one. F of x means is just the original function that we have right there. Okay, and then divide by h. Now, everything is set up for f of x plus h. Now, I'm going to plug in everything in this equation. So let's go and plug it in. For example, the function I have, I'm going to write it again because we can see it now. F of x plus h minus f of x over h. So let's plug in f of x plus h, which we got right there. So it's going to be negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5 minus that minus f of x. F of x means the original function that we had. So our original function, and I'm going to put parentheses there so I know that's the original one, minus 2x squared plus x plus 5 enclosed. In the bottom, we have h, which is going to stay. Now, let's distribute because we have to get rid of the parentheses. So this is invisible one, so the negative is going to go negative, negative is going to go positive, negative is going to go another positive. So let's try that, and then we combine like terms, if we have any. 4xh minus 2h squared plus x, I don't know why I'm saying x plus h plus 5. Negative times negative is positive 2x squared. Negative times positive is negative x. Negative times positive is negative 5. Everything is what? h. Now, do I have any like terms here? Yes, we do. 2x squared and negative 2x squared. So they cancel out. I have x and ax. They cancel out. I have 5 and 5. They cancel out. So I'm left with negative 4xh minus 2h squared over h. Okay, this is everything left. Now let's do, I can't do anything with this, but other than common factor, which is h in this case. So if h is common factor, then I'm left with negative 4x minus 2h. You know, I took out the h, so this h disappear, and that is only one h left inside, and I'm gonna go divide h. You know, they cancel out.
And this would be the case every time you get something like this. You have to, at the end, you have to factor it out, something, common factor. So I'm left with negative 4x minus 2h. Do I have anything else there? Oh, I had this h. I forgot that right there. So I should have plus 1 here. And that's plus 1. And that's my answer. We can't do anything with that. Okay, so that's how we're gonna deal with these questions. Make sure that you understand this one. You're gonna see them a lot in pre-calculus, in AP calculus, these ones. As long as you plug this in correctly, replace x with that. And also, it's always gonna be a common factor that you can cancel out the bottom h with it. Okay, please like my video. If you have any questions, comment below. I can help you with anything you want. I can make a video for you guys for the question. And also subscribe my channel. I would appreciate that. Thank you and have a good day.